So my name is Yvan Large. I'm a principal engineer, system architect at Intel. As I don't need to introduce Intel, but Intel is pretty much moving in the compute space. And over the summer, Raja kind of highlighted the 6 pillars strategy during the architecture day of Intel. Several of them are definitely applying to the HPC market. And what we see ahead of us is many challenges into the HPC market. So compared to the AI machine learning kind of market, there's a different mix of CPUs, GPUs, accelerators, network and storage at this point. So that this is something that is something that we need to look into. I'll be briefly looking into scalability more and issues on going into more compact. Also challenges on the density. I think Alan and Phil also talked about it. Issues around the flexibility, faster and lower latency, and then some how do we make this more efficient as well. So what we see at Intel is actually an opportunity compared to the OCP market, where currently we're operating on the 8 accelerators per one CPU, per 2 CPUs. Here, I think we see an opportunity to operate in the 4-to-2 for OEM or PCIe sockets, and compared to 2 CPUs. So we definitely see an opportunity in that space, and this is going to be helping us driving more density and HPC throughput as well. So this is where we believe we should be operating, and then the strategy that we have at Intel is actually with a chiplet approach or tile. We're in a position to kind of expand the number of accelerators there per sockets, per OEM or PCIe sockets. So of course, as we start increasing the number of accelerators within a given U form factor or a given rack, then definitely we see challenges ahead. The power density increases, as Phil was mentioning, and we need to also find better and more adequate cooling solutions. So other than air cooled, liquid cooled, what do we need to start looking into for something that will be capable of addressing the future solutions? And then, of course, as we stack more and more accelerators and CPU, the interconnect and the speed definitely need to increase as there's more and more data being exchanged and compute. So what we see is the traditional interconnect in terms of connector cables and so on become the bottlenecks here. So we need to reinvent or to think differently on that side. And I think this is part of what Alan kind of mentioned at the beginning. So from that perspective, interconnect and the system architecture also will be key on how do we kind of remove these bottlenecks and think beyond that. As well, so from a lower, excuse me, as we move to faster speeds and lower latency, is how do we remove and that the speeds increases over the interconnect, and how do we start? There's going to be a concern whether we need to add retimer switches, and this is going to be adding even further latency as well on the path. So how do we start approaching this at the system level to make sure that we have an acceptable trade-off between power being handled at the retimer switches and the traditional interconnect, and how do we bypass these solutions or use different solutions. So overall, the system architecture is going to be key there to start thinking how we're going to be starting to optimize to address faster speeds and lower latencies as well. So overall, as we keep driving towards like more density, more speeds, higher speeds, it becomes evident that as Phil was saying, is like, there's a trend moving towards like, from 12 to 48 volt. We need a lot more power within rack. But also we need to kind of align on the input voltage that will help to kind of, standardize and simplify at the rack level and at the chassis level. That's going to help also at the conversion to also simplify and also to become more efficient. But as Phil was saying, the bottleneck after that is going to quickly become the rack power. So we're going to need to start thinking about, from a rack power strategy, what's next, and how do we remove that barrier or think differently at this point. So call to action: join the HPC community here that Alan is driving, and then looking forward to the questions that you have.